We can do vector addition to these velocities, which are vectors, and basically we'll be subtracting one from the other. And so we can always do that when they're parallel to each other. The velocity of the current is 1 kilometer per hour, and the velocity of the canoe is 5 kilometers per hour. And so if we define a positive direction as up and to the right, that means the velocity of the current is negative. And so if we find the sum of the velocities in the vertical direction, we could see they would subtract, and we would be left with 4 kilometers per hour. Resultant just in the vertical direction is 5 minus 1 equals 4 kilometers per hour. We'll use 4 kilometers per hour for this forward velocity. Next, we have the velocity of the wind is against the canoe at an angle of 30 degrees east from the path of the canoe. So how do we draw that? Well, you can see how it's drawn here already, but with vector addition, remember we have to do tip to tail. So we write the tip of the resultant canoe velocity next to the tail of the wind, which was 2 kilometers per hour. And so we have a tip always meeting with the tail when we're doing vector addition. Finally, we can determine our resultant is from the tail of the first vector to the tip of the final vector. So we're finding this resultant. So how do we find the resultant? Remember, we're given the angle. The wind is at an angle of 30 degrees east of the path of the canoe. And so if that's 30 degrees, then we could see maybe that this little angle in here is also 30 degrees. So we can say the angle in our triangle is 30 degrees. And that's all we need. So we can solve for the resultant when we have the side, angle, and another side. What do we use to solve a triangle with side, angle, side? Do you remember? Side, angle, side uses the cosine law. So we're going to use the cosine law. Cosine law is generally that side length A squared equals side length B squared plus side C squared minus 2bc times the cos of the opposite angle of side length A, big A. For little a, we'll call the resultant little a. And so we'll call this angle that we have big A. We'll call this side length B and this side length little c. And so now we can plug in and solve. So we have our side length B, side length C, and angle A. And now we can substitute in to solve for the side length A, or our resultant. Simplifying this on the calculator, we would get 6.14. Therefore, A equals positive root of 6.14, which is 2.5 kilometers per hour. Now, we could also find the angle theta from the initial position. We should, because we have an angle that's given, and our resultant is a vector. Remember, vectors require an angle. Solving for this angle, we could use sine law. The sine of angle theta over the opposite side length, opposite from theta is the 2, equals the sine of any other opposite angle in pair. So we have this angle 30, and opposite from it, it's paired with the magnitude we just solved for, 2.5. Rearranging this, we can cross multiply the 2 up to the top here. And so theta equals the inverse sine. On the calculator, this equals 23.6 degrees. So we would say this is 23.6 degrees towards the west from the north. So we have north 23.6 degrees west.